Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And over the last few days, I've talked about something called cyclonic curvature and anticyclonic curvature. And you may be asking yourself, what the heck is that? And so that is the subject for the bonus weather video today. So I will put myself down here in the corner so you can see the graphics. And this is just some basic review. I'm sure you all know this, but the winds in the northern hemisphere rotate around areas of high pressure in a clockwise manner and around low pressure areas in a counterclockwise manner. In the southern hemisphere, it's exactly the opposite, and that's because the Coriolis force is aimed in a different direction. Instead of everything being deflected to the right because of the Coriolis force, it's deflected to the left, and so that changes everything. So high pressure is counterclockwise and low pressure is clockwise, and I swear I would have an awfully hard time getting used to that if I was displaced to the southern hemisphere and had to forecast the weather. So let's take a look at high pressure areas first here and anticyclonic curvature and see if we can make any sense out of this. So here I've drawn a couple of isobars around this area of high pressure, and I've got that one arrow there denoting the fact that the wind is going in a clockwise manner. Now, there are two forces that are balanced here, okay? The first one is the pressure gradient force. Now, you may remember us talking about this, and the pressure gradient force is always directed from high pressure to low pressure. So it would be directed out of the area of high pressure, away from it. And you would see that same thing all the way around here, okay? It would be out here, out here, out here, and so forth. The Coriolis force is always directed to the right of the wind, okay? And so as a result of that, the Coriolis force is directed inward toward the area of high pressure. And again, that's the same all the way around the system, always directed in. Well, the weather is never interesting when everything is balanced, okay? And so what comes into play here is something called friction. So that's the Coriolis force there. So the pressure gradient force and the Coriolis force are balanced, and as a result, the wind blows in a clockwise manner around the high. However, there is something called friction, and friction is greater over land than it is over water, but even over water you do get it to some degree. And so friction slows the wind down, okay? And the Coriolis force, it turns out, is proportional to the wind speed. So what happens? The Coriolis force lessens in intensity. So instead of having a long arrow pointed toward the middle of the area of high pressure, now it's a short arrow, and there is an imbalance of forces now, okay? So the pressure gradient force is dominating. As a result, the winds actually blow away from the area of high pressure. They're no longer completely balanced, and so the air is diverging or spreading out from the high, and when air diverges, it leads to sinking motion because the air is going apart here, so something has to come in to replace it, so the air sinks and it warms up and dries out. And that's why areas of high pressure are one of the reasons why they're associated with, fair weather and pretty nice conditions overall. So that's the high. That is anticyclonic curvature. And again, the winds end up diverging away from the high. Okay, now we get to low pressure areas or cyclonic curvature. So here I've got my two isobars, and my arrow is again denoting the fact that the wind circulation is going around the low in a counterclockwise manner. The pressure gradient force is now directed inward toward the low. It always goes from high pressure to low pressure. And the Coriolis force is to the right of the wind, and so it's directed away from the area of low pressure. And so you have a balance of forces, and the wind goes in a clockwise manner, counterclockwise manner around the low. But again, friction slows the wind down, okay? So the Coriolis force is proportional to the wind speed, so the Coriolis force lessens. So instead of having a big arrow directed out of the area of low pressure, it is a small arrow now, and the pressure gradient force is dominating, but this time it's dominating going toward the low and not away from the high, okay? So the wind then blows across the isobars and converges, okay? So instead of it being a balanced flow, it's an imbalanced flow, and because of that imbalance, the wind actually blows across the isobars and sort of spirals in to the center of the low. So when air converges, it leads to rising motion, okay? Air's coming together, it can't go down into the mud, so it's got to go up. and that leads to cooling and moistening, and if it cools and moistens enough, then you end up getting clouds and precipitation. So friction plays a major role in the way the wind blows around areas of high and low pressure. If friction was not a force at all, then things would be balanced and the weather would be fairly boring, okay? But this livens it up quite a bit, but just by nature of the fact that we have this imbalance of forces due to friction. All right, folks, that is the dirt on cyclonic and anticyclonic curvature in the Northern Hemisphere. And that is it for today. The next bonus weather video will be coming up on Friday. The next daily weather update, of course, will be coming up tomorrow afternoon. So hope you have a wonderful Wednesday evening, and we'll talk to you again tomorrow. See you later, folks.